Hello everyone. Today we will see how to program the 8051 target device. So we have a 8051 target device. We have a key compiler, and we will write a sort of programming like Blink LED, and we will see how exactly we can program, compile it, and finally flash the hex file into the target device. So here we have 8051 development board. You can see here. This is the 8051 development board that we have with us. So it consists of processor here. This is the processor that we have here. So this is the 8051 microcontroller, and you can see here this device is an USB cable which is connected to the PC USB port here. So and what else we have here is an LCD display and a reset connection, and these are the two IO pins that are used for an IO signaling for the skip. And along with that, we have here a development board. Now, this development board basically consists of switches and LEDs, and it is connected with an FRC cable. This is an FRC cable, 26 FRC cable, which is connected to the kit here. So this is a kit. So to this kit, this FRC cable is connected, and here this FRC kit contains carries all the port signal. Like 8051 is having port 0, port 1, port 2, and port 3. Altogether, 4 ports are there, but only 3 ports are connected to this FRC cable output. So port 2 is not connected. Port 0, 1, and 3 is connected to this FRC cable, and signaling is given to the. So we have to see which port. So this particular development board which we have manufactured, so is these LEDs are connected to port 0, and switches are connected to port 1. So we are going to use all these peripherals for the programming. So this development board, like this 8051 family, is actually programmed using a serial bootloader. So this USB is having a USB to serial bridge connector. There is an FTDI series which is connecting, which is converting this USB protocol to the serial protocol and used to program this 8051 code. So how this is to be connected? So once you connect this USB port to the PC, you have to see which port it is connected. So we will see how this 8051 can be connected. So as you connect this board to the PC, you can see that. So you can see a new COM port is getting created. So now we are in the scale microvision application. So here is a Blink LED program. Now how to compile the scale that is there in my previous video. Now this program we will flash to the target device which I just shown. So once you are able to compile it, you have to see which device is going to be connected. So to go to the option for the target and select the format here, the debug format. So now by default, it will be in the simulation mode here. So this is, there won't be nothing over here. So this is going to be the simulation mode. So what you need to do is you have to use this in the one of the option provided. So what we are going to use here is keil monitor 51 driver. So this is the option to be selected. So you select this option, and then you can build this project once again. So once you are able to build this project, it generates a text file with the name Blink. Now this has to be loaded to the target device. So now we should vary which is the target device right now that is supposed to select. For that, I'll be now you have to check in which port this USB device is connected. So for that, you should go to the device manager. So just in the uh, search menu here, just type device manager. So you will get the device manager here. And in this device manager, you have to find the port. So if your USB device is connected, so this is the device. COM3 is a USB serial port which we connected to the PC, USB slot of the PC. So this COM3 is to be put when you are programming this 8051. So COM3 is a number, remember that. So once it is done, so what you need to do is go to the debug option and just click start stop debug session. Once you do that, you can ask for the code limit, and since it won't be connected because there is a mismatch in the port number. So what you need to do is, so you see these options here. So which is the port that by default is getting connected? It is a COM1. So we need to select COM3 here so that the port is supposed to match. So whatever the hex file that we generated has to be loaded to the same port where this FTDI, your USB device is connected. So select that and just put try again. So once you do that, so the now the GUI will change. It will go back to the debug window. So here is a debug window that appears, and you can see here this is the hex files. This is the hex file, the machine language, and this is the assembly language, and these are the registers. Most of the things you can just check it out here. Now let me run this code. So for the running the program, you need to go here to the run option. So once you click run option, you can find that the program in the target device is now loaded, and you can able to run this. So this is how now the program is executed. You can see where it is, how this is running. So here is a result where I connected this port 0 here. So this is the LEDs which we connected. So these are the LEDs, 8 LEDs, and now they are blinking. That is connected to the port 1, port 0. So port 0 we have actually in the program we connected it to port 0. That's why it is blinking. So this is how the blink action you can perform using the 8051. So here is the target device. The target device is now running, and the signaling is sent through port 0, and from here this LED is blinking. So this is how you can blink the LED. Now if you look at the code, you see here the port 0 is loaded with 00 for initial setting. The later accumulator is loaded with 00, and that will be sent to the port 0, which will turn off the LED, and later the delay is called, and then FF is loaded to port 0 and delay is called. This procedure repeats, and you get the blink of the LED. So this is how the LED blink is achieved using a serial programmer, which is an inbuilt bootloader with the 8051 target device and a external interfacing device.